Today, I will take you to the brightest star in the night sky. Sirius, the dog star. The star that locks your eyes the moment you look up on a winter night. City light pollution can't stop its glow. And hidden inside its stellar evolution are cosmic secrets that will upend everything you thought you knew. You look up and see Sirius, blazing beyond imagination. It is 25 times more luminous than our Sunday. Even from the middle of a neon-lit city, you can spot it hanging there, unmistakable. It is the brightest star visible to the naked eye in the entire night sky. And this brilliance is no accident. It is the product of innate advantage compounded by circumstance. Sirius is only 8.6 light-years from Earth, making it part of the fifth closest star system to our Sunday. It is a hot, blue-white main-sequence star with a surface temperature of around 10,000 Kelvin, nearly twice that of our Sunday. It carries about twice the mass of the Sun and a diameter 1.7 times larger. Big, close, and blazing hot. That combination makes it the undisputed king of brightness in the night sky. But Sirius holds a harder secret, one buried in plain sight. It is not a single star at all. It is a binary system. The dazzling light we see with the naked eye comes from the main star, Sirius A. And orbiting silently beside it is a deadly companion, a white dwarf called Sirius B. Sirius B is extraordinarily small, only about 7,500 miles in diameter, roughly the size of Earth. But it packs a mass nearly equal to our entire Sun into that tiny volume. The density is almost incomprehensible. On the surface of Sirius B, gravity is 400,000 times stronger than on Earth. A sugar cube-sized piece of its material would weigh over a ton. What makes this pair even more remarkable is how they move. The two stars orbit each other on a 50-year cycle, tracing a highly elliptical path. At their closest, they are about 8 astronomical units apart. At their farthest, nearly 32 astronomical units close to the distance from the Sun to Neptune. And Sirius B is not just a curiosity. It is one of the most historically significant objects in all of astronomy. When it was first confirmed in the 19th century, it became the first white dwarf ever identified. That discovery gave direct observational proof to what had previously been only theoretical. That intermediate mass stars like our Sun, after exhausting their core fuel in old age, expand into red giants, shed their outer layers, and collapse their cores into an incredibly dense, incredibly small white dwarf. Sirius B was the moment theory became fact. Beyond the mysteries of its binary system, Sirius is also one of the most valuable observational tools in astronomy. Because it is so bright and so close, it serves as a physical reference star for studying stellar properties. By reading its spectrum, astronomers can precisely analyze the elemental composition of its atmosphere, roughly 73% hydrogen, 25% helium, with traces of heavier elements like carbon, nitrogen, and oxygen, closely mirroring the composition of the Sunday. That similarity makes it a crucial reference point for understanding how stars form. And the gravitational dance between Sirius A and B allows astronomers to accurately calculate each star's mass and study the mechanics of binary orbital motion. For anyone starting out in astronomy, Sirius is the perfect first target. No telescope required. Just step outside on a winter night and look south. But with even an entry-level telescope and a night of good seeing conditions, you may be able to spot Sirius B itself, a faint pinprick of light nestled in the blinding glare of its companion. What makes Sirius even more profound is what it represents at scale. Binary and multiple star systems like this one are not rare. Astronomers estimate that more than half of all stars in the universe exist in pairs or groups. Sirius is not exceptional. It is normal. It is the rule. And its white dwarf companion is not just a dead ember. It is a preview. Billions of years from now, our own Sun will exhaust its hydrogen fuel, swell into a red giant, shed its outer layers into a planetary nebula, and collapse into a white dwarf not unlike Sirius B. That tiny, dense object, orbiting quietly 8.6 light-years away, is showing us our Sun's final form. Every photon of light that travels 8.6 light-years to reach your eyes carries a record of stellar evolution, a code written in nuclear physics, gravity, and time. When you look up at Sirius on a winter night, you are not just seeing a bright star. You are reading a chapter of the universe's autobiography. A chapter that includes the past, present, and ultimate future of our own solar system.